Let's go ahead and do another physics problem. Jane travels by car from one city to another. She drives for 35 minutes at 78 kilometers per hour, 12.6 minutes at 102 kilometers per hour, 49 minutes at 47 kilometers per hour, and then she spends 25 minutes eating lunch and buying gas, during which time she's not really moving at all. She's not traveling at all. Determine the average speed for the trip. Now, with this type of problem, you've got to be careful. A lot of students, their first inclination is to find the average velocity for each segment of the trip, add all those velocities up, divide by, in this case, 4, and that's their average velocity. Wrong. You're going to get the wrong answer. Think of it as kind of a weighted average. You just can't add everything up and divide by the total amount because the different segments are not equal. So what we're going to have to do here is something a little bit different, a slightly different approach. Let's go ahead and draw a diagram first, just to kind of make things more clear. All right, so there's 4 legs to this trip. So let's kind of do them in order. So here's leg number 1. There she is, there's Jane, and that's her first leg. All right, time is going to be, I'll call this T1 because there's 4 times. This is going to be 35 minutes. And the average velocity that she was traveling at, so we'll call that average velocity 1, is 78 kilometers per hour. So there we go. And that's the first leg of her trip. So let's go ahead and do the second leg. There it is. And here she travels, we'll call it T2, 12.6 minutes. And average velocity, so V sub 2 average, is going to be 102 kilometers per hour. There we go. Number 3, the third segment, time T equals 3, or T3 equals 49.0 minutes, and her average velocity here, so we'll call that V sub 3, was 47.0 kilometers per hour. And in the final leg of her trip, I'm just going to draw a big old dot, a big old point mass there. And let's see, T4. We'll make this T4. And that was 25 minutes. And the average velocity was 0 because she wasn't moving. All right, so there we go. And as I said early on, you just can't, take these 4 velocities, add them up and divide by 4 because they're not equal to each other. It's kind of like a weighted average. So this is what we're going to do. I'm going to write down my formula. Average velocity equals displacement over time. And I want to find the average velocity for the entire trip. So what I want to do here, because I'm looking for this, is if I want to find the average velocity for the entire trip, I need to find the displacement for the entire trip, and then divide that by the total time for the entire trip. So this is what I'm going to do. I'm going to go ahead and find the displacement for each one of these segments. And obviously, x sub 4, it's going to be 0, right? Because she's not moving. So that one's pretty easy. We got to do the other 3. So let's go ahead and find our displacement. We do have average velocity and we do have the time, so that kind of makes things easier. Average velocity equals displacement over time. We know the average velocity, 78.0 kilometers per hour. And by the way, what I'm going to do here is I'm going to leave kilometers per hour. I'm going to leave it there. I'm going to leave it in that form. Now, if you're uncertain about this, convert everything to meters per second and convert all your times into second, and you'll get the right answer. But just to make the math a little bit easier here, I'm going to leave this in kilometers per hour, and then what I'm going to do is I'm going to change the minutes into hours, And that way my hours will cancel out and I'll be left in kilometers, which is a length. So I'm going to do that. So by using dimensional analysis, go ahead and convert 35 minutes into hours. So I'm just going to kind of give you what that, I'm going to write it like this. 35.0 minutes. I'll put that over 1. And I want to convert that into hours. So there's my conversion factor. I need minutes down here, and I want to get it into hours. So I'm going to what I'm going to do is I'm going to put 60 minutes down here and 1 hour up there. Now my minutes will cancel out, and I'll be in hours. And then I'll put X on top. So ultimately what I'm going to do is I'm going to go 35 divided by 60, get a number, and then I'm going to multiply that by 78, and that's going to give me my displacement. So 45.5 kilometers. I'm going to underline that just to draw my attention to that. All right, let's do the same thing for the second segment. Average velocity equals displacement over time. The average velocity is going to be 102 kilometers per hour equals displacement. The time is 12.6 minutes. I'm going to make a fraction out of that. That's the form I needed in for dimensional analysis. And my conversion factor, 60 minutes equals 1 hour. Again, I want minutes on the bottom, so it cancels the minutes on top. When I do the math, 12.6 divided by 60, I take whatever that is, multiply it by 102, and then that gives me 21.42. So 21.42 kilometers. So there I go. Being careful, I don't want to round off just yet. These are not final answers. Let's go ahead and do it with segment number 3. Average velocity equals displacement over time. And again, every time you do a calculation, write your formula, substitute in the numbers, and an answer. It's just easier. Remember, you're communicating. You're communicating with other scientists, with your teacher, with other students, and you need to show them step by step by step how you do something. You can't just say, believe me, I know what I'm doing, all right? It doesn't work in science. All right, average velocity, 47.0 kilometers per hour equals displacement, and the time is 49 minutes. So 49.0 minutes over 1, 60 minutes in 1 hour, and 49 divided by 60, get a number, multiply that by 47, and I end up with a displacement of 38.383. So 38.383 kilometers. So there we go. This would be obviously x sub 1, x sub 2, x sub 3, x sub 4. So now what I want to do is I want to take all these displacements, add them up, and that's what I'm going to put in for my wrong formula. That's what I'm going to put in for my displacement here. All right, so this was the formula we originally wrote down. I'm trying to figure out the average velocity. So what I want to do is add up all 4 of these. When I do that, I'm going to get, doesn't look like I got a number for that. I did it all in one shot. Now let me go ahead and do that down here. So average velocity equals displacement over time. The average velocity is going to be 45.5 kilometers plus 21.42 kilometers plus 38.383 kilometers plus 0 over the total time. So I want to add up all these times. 35 minutes. Let's go ahead and do this. 35.0 minutes plus 12.6 minutes plus 49.0 minutes plus, we do have a time here, so we need to include this. Don't forget that. She didn't travel anywhere, but time does pass. So 25.0 minutes, that's important. And right now I'm in kilometers per minute, and I want to be in kilometers per hour. So what I'm going to do is I'm going to make a big fraction out of this time and multiply that by a conversion factor. Again, 60 minutes equals 1 hour. And this is the way I did it, but you know, you could just add these up and substitute that in. You could, maybe you figured out the exact number of hours earlier. You could just substitute that in. This is just kind of the way I did it. It's a little long, but it works. All right, put all the numbers in your calculator, and what you're going to end up with is 51.958. 51.958 kilometers per hour. Kilometers per hour. And if we round off, we got, looks like 3 significant digits, 3 significant digits. It would be 52.0 kilometers per hour. So I'm going to go ahead and put a box around that. That's my answer, 52 kilometers per hour. That's going to be my average velocity for the entire trip. All right. On top of that, part B was determine the total distance traveled. So that's pretty easy. Just take your displacement here, here, and here. Now she's constantly heading in one direction. She doesn't double back at all. She doesn't take any 90-degree turns. She's going in a straight line, let's say in that direction. So the magnitude of the displacement and the distance are going to be the same here. So if you just take each of these 4 numbers, add them up, that's going to be the total distance. And that would be, after you round off, 105 kilometers. 105 kilometers. All right, that's going to be it for this problem.